Hello everyone, my name is Jonathan and welcome to my video discussion about IT Essentials version 7. In this video, I will be discussing the last two sections of Chapter 5 Networking Concepts. In Section 5.3, we will talk about different network devices that are being used in a network environment. We will try to learn the characteristics and functions of each device. In Section 5.4, we will be talking about the purpose and characteristics of the different types of cables that we use in the network. So let's get started. For a device to be connected or have an access to the network, it needs to have a component that will physically connect the device to the network, and that is the Network Interface Card or NIC. Ethernet NICs are used to connect to Ethernet networks, and wireless NICs are used to connect to 802.11 wireless networks. For some, NICs of desktop computers are connected to an expansion slot. For most computers as well as laptops, and even small devices such as Raspberry Pi, NICs are already integrated into the motherboard. NICs are also available in a USB form factor. Aside from connecting the device to the network, another important thing that this component does is that it provides a unique identity to the device, and that is the MAC address. This address is used and appended to the data before it is being sent out to the network. Let us now discuss network devices that are commonly being used in any company or organization. The first one is the repeater. This device simply amplifies or re-strengthens the signal. It also extends the distance that the signal can travel. Every cable has its maximum distance length. If you go beyond that length, the signal becomes weak or will be lost. To avoid that, a repeater is being placed in order to re-amplify or re-strengthen the signal so that the signal can travel farther. A multiple repeater is called a hub. It has the same function as the repeater, but with multiple ports. Data sent to this device will be broadcasted or sent out to all other ports except the originating port. This kind of process consumes too much bandwidth, which could cause a slowdown in the network traffic. By the way, repeaters and hub are under the layer 1 of the OSI model, which is the physical layer. Over time, another device that has been developed in order to address the limitations of the hub, and that is to segment network traffic. Traffic segmentation is important to improve the bandwidth usage in our network, and this device is called the bridge. What it does is that it keeps a record of all the devices in each segment, and then, as the signal is sent to the bridge will check the saved information of all devices in each segment, and then sends the signal to the intended destination. This helps in reducing the amount of traffic between devices. A multiport bridge is called a switch. It also implements microsegmentations, just like the bridge. It filters and sends data only to the intended destination through the use of the MAC addresses of the devices attached or connected to port of the switch. These MAC addresses are stored in the MAC address table, and this is what the switch is using to determine where to forward the data. These switches can be managed or unmanaged. Typically, managed switches are being used in larger networks where other switch functions are needed, such as VLANs and port security. For unmanaged switches, these are switches used in small-scale networks like home or small business where no other functions are needed except for microsegmentation only. These bridges and switches are under layer 2 of the OSI model, which is the data link layer. Another device that is always present in an organization is the wireless access point. These devices simply extend our network connectivity through wireless. It means that we can connect our mobile devices anywhere and without using cables as long as we are within our local area network. Next device that plays an important role in networking are routers. These devices are under layer 3 of the OSI model, which is the network layer. Basically, router forwards traffic using an IP address attached to the data packet. These routers act also as a gateway to the outside networks. It means that any data from the local network destined to outside networks must pass through the router device to determine the best path to reach the target destination. I hope that you understand what we have discussed so far. If you want to know more details of these network devices, I encourage you to take the CCNA Switching, Routing, and Wireless Essentials Module version 7. Now that we have learned what networking is all about, as well as how networking devices works in our network, we need to understand also the importance of network security. We need to take care of our data as well as our network infrastructure. That is why, aside from the devices that allows us to connect to another device to share our information and resources, there are important devices also that will keep our data and resources safe from any intruders. The first security device is a firewall. It is a network appliance that protects data and equipment from unauthorized access. It allows or denies access to network resources or services. Next, we have the intrusion detection system and intrusion prevention system. The intrusion detection systems, or IDS, passively monitor traffic on the network. What it does is that it tries to detect any anomalies with the traffic that is moving in and out of the network. Once detected, that is the only time to resolve issues caused by that anomalies. On the other hand, with intrusion prevention system, or IPS, it will not allow any packets to move in and out of the network without being analyzed first. The main difference between IDS and IPS is that with IPS, it responds immediately and does not allow any malicious traffic to pass. Whereas with IDS, it allows malicious traffic to pass before it is addressed. Another device is the Universal Threat Management. It is an all-in-one security appliance, meaning to say it has firewall services and IDS, IPS services, and other security services, as you can see on the screen. Definitely, this is one of the devices that most companies are looking for because it will save them a lot of money. Best example of this next generation firewall is the one that you are seeing on the screen, the Cisco Adaptive Security Appliance. An endpoint management server is typically responsible for monitoring all the end devices in your network, including desktops, laptops, servers, tablets, and any device connected to your network. It can restrict an end device connection to the network if the device does not meet certain predetermined requirements. Cisco's Digital Network Architecture, or DNA, Center is an example of a solution that provides endpoint management. However, Cisco DNA is much more. It is a comprehensive management solution for managing all devices connected to the network so that the network administrator can optimize network performance to deliver the best possible user and application experience. Other network device that we are seeing in a network control room is the patch panel. A patch panel is commonly used as a place to collect incoming cable runs from the various networking devices throughout a facility. It provides a connection point between PCs and the switches or routers. Next, we have a cloud-based network controller. It is a device in the cloud that allows network administrators to manage network devices. An example of this is the Cisco Meraki, which provides cloud-based networking that centralizes the management, visibility, and control of all Meraki devices into one dashboard interface. The network administrator is able to manage the wireless devices in multiple locations with just a click of a mouse button. That concludes the discussion of the different network devices. Let us now discuss copper cables and connectors. Coaxial cable is made up of either copper or aluminum. It is typically used by both cable television companies and satellite communication systems. Coaxial cable is enclosed in a sheet or jacket and can be terminated with a variety of connectors. This cable carries data in the form of electrical signals. It provides improved shielding compared to unshielded twisted pair or UTP. So it has a higher signal-to-noise ratio, allowing it to carry more data. This cable is harder to install, more expensive, and harder to troubleshoot. Thin net cable runs for about 200 meters, while thick net cable runs for 500 meters. Twisted pair, on the other hand, is cheaper than the coaxial cable. Electrical signals also passes through this cable. In this type of cable, the pair is twisted to provide protection against crosstalk. This crosstalk is the noise generated by adjacent pairs of wires in the cable. There are different types of twisted pair cables. The most common is the unshielded twisted pair or UTP. Basically, UTP cable consists of 4 pairs of color-coded wires that have been twisted together and then encased in a flexible plastic sheet that protects from minor physical damage. This cable is not immune with electromagnetic interference or radio frequency interference. That is why we should not install these cables close to our electrical wiring or fluorescent lights. To address the limitation of the UTP, shielded twisted pair was designed. In this cable, the twisted pair is wrapped with a foil shield or a metallic braid to protect against EMI and RFI. But of course, this type of cable is more expensive than the UTP because of the mentioned added materials. Both UTP and STP cables are terminated with an RJ45 connector and plug into RJ45 sockets. In choosing which type of twisted pair to use in your network depends on the company's requirement and the category ratings of the twisted pair. As you can see on your screen, each category has their own speed capacity as well as their features. You may check on these category ratings later as you do further reading of this topic. I have mentioned earlier that both UTP and STP are terminated with an RJ45 connector. Alongside this connector, there are 2 ways on how to terminate these cables. These are the T568A and T568B. Each wiring scheme defines the pin-out or order of wire connections on the end of the cable. If you will notice, only the orange and green pairs are interchanged. By the way, in my next video, I will show you how to properly terminate a UTP cable. Another cable that is common in our network infrastructure is the fiber optic cables. This type of cable uses pulses of light to transmit signals. This means that it is not affected by EMI or RFI, unlike twisted pair cables. It has a greater bandwidth than copper cables. It is composed of the following materials: First is the jacket. Typically, a PVC jacket protects the fiber against abrasion, moisture, and other contaminants. This outer jacket composition can vary depending on the cable usage. Next, we have the strengthening material. This surrounds the buffer, prevents the fiber cable from being stretched when it is being pulled. The material used is often the same material used to produce bulletproof vests, and that is the Kevlar. The buffer is used to help shield the core and cladding from damage. Cladding is made from slightly different chemicals than those used to create the core. It tends to act like a mirror by reflecting light back into the core of the fiber. This keeps light in the core as it travels down the fiber. The core is actually the light transmission element at the center of the optical fiber. This core is typically silica or glass. Light pulses travel through the fiber core. The single-mode fiber consists of a very small core and uses laser technology to send a single ray of light. Its maximum cable run is 3 kilometers. The multimode fiber consists of a larger core and uses LED emitters to send light pulses. Its maximum cable run is 2 kilometers. These cables are typically used for the riser or backbone subsystem of the network. The connectors that we use for fiber optic cables are the following. First is the straight tip or ST connectors. One of the first connector types are used. The connector locks securely with a twist-on or twist-off bayonet-style mechanism. Next is the LC connector or the lucent connector. It is a smaller version of the fiber optic SC connector. It is sometimes called a little or local connector and is quickly growing in popularity due to its smaller size. The subscriber connector, sometimes referred to as a square connector or standard connector. It is widely adopted LAN and WAN connector that uses a push-pull mechanism to ensure positive insertion. This connector type is used with multi-mode and single-mode fiber. Lastly, we have the duplex mode or duplex multi-mode LC connector. This is similar to a LC simplex connector but using a duplex connector. That ends my video discussion of Chapter 5. Please do not forget to do all activities in our module to check your understanding about the topics being discussed. I hope also that you will watch my video about UTP cable termination. If you have any questions, you may post a comment in our discussion board or you may ask me during our live session. Thank you very much.